What are the ways to convert between AM and PM and 24-hour time?
When converting AM/PM to 24-hour time for the hours between 12 AM and 12:59 AM. Just subtract 12 from the time. For instance, 12:45 AM minus 12 will equal 0045, and 12:59 AM minus 12 will equal 0059 times between 1 AM and 12:59 PM are a straight conversion. Such as 9 AM equals 0900 and 11 AM equals 1100. For the conversion between 1 PM and 11:59 PM. Add 12, such as 8:34 PM plus 12 equals 2034, and 11:59 PM plus 12 equals 2359, also seen as 2034 and 2359. To convert in the opposite direction from the above, add 12 for the hours between 0000, midnight, and 0059, such as 0034 plus 12 equals 12:34 AM, and 0059 plus 12 equals 12:59 AM. 2. Convert from 0100 to 11:59 and from 1200 to 12:29, there is a 1-to-1 conversion. The former to AM and the latter to PM. For example, 0100 equals 1 AM, 0345 equals 3:45 AM, 1235 equals 12:35 PM. And 1259 equals 12:59 PM. To convert between 1300 and 2359, subtract 12, such as 1424 minus 12 equals 2:24 PM. And 2359 minus 12 equals 11:59 PM. How are local A.M/P.M?
What is a partial derivative?
Partial derivatives, seen written as the symbol a, are derivatives of a function containing multiple variables that have all but the variable of interest held fixed during the differentiation. Thus, when a function f, x, y, depends on more than one variable, the partial derivative can be used to specify the derivative with respect to one or more variables. There are other terms, too. Partial derivatives that involve more than one variable are called mixed partial derivatives. And a differential equation expressing one or more quantities in terms of partial derivatives is called, logically, a partial differential equation. These equations are well known in physics and engineering, and most are notoriously difficult to solve.
What happens when you multiply a matrix by the identity matrix?
When you multiply any n by n matrix by the identity matrix, you get that same matrix back again. Therefore, let the letter I represent the n by n identity matrix, and A represent any other n by n matrix. We then have AXI equals A and IXA equals A. This is much like the situation when using the real numbers, x(1 equals x and 1x equals x.
How can the base of logarithms be changed?
The base of logarithms can be changed from one that is not 10 or e to an equivalent logarithm with base 10 or e. The following gives the formula for such a transition, in which a, b, and x are real positive numbers, but neither a nor b are equal to 1, and x is greater than 0. Convert log x to the base b by using the formula, log(x) / log b.
Why is there such a demand for applied mathematics in the processing of images?
The field of image processing has grown immensely in the past few decades. There is a great demand for an increase in efficient processing of images, especially for multimedia, biology, and medicine, such as enhancing the quality of electron microscope and MRI, magnetic resonance imaging, images. In addition, there is a great need to develop ways to store more and more information, especially regarding methods in transmitting and processing the information used in computers and networks. All of these things require the use of several mathematical techniques and thus, the use of applied mathematics.
What does Einstein's famous equation E equals mc2 signify?
Among his other accomplishments, Albert Einstein showed mathematically that there was a connection between mass and energy, energy has mass, and mass represents energy. This equation, also called the energy-mass relation, is expressed as E equals mc2, in which E is energy, m is mass, and c is the speed of light. Because c is a very large number, even a very small amount of mass represents an enormous amount of energy.
How did the Sumerian written counting system change over time?
Around 3200 BCE, the Sumerians developed a written number system, attaching a special graphical symbol to each of the larger numbers at various intervals, 1, 10, 60, 3600, etc. Because of the rarity of stone, and the difficulty in preserving leather, parchment, or wood, the Sumerians used a material that would not only last but would be easy to imprint, clay. Each symbol was written on wet clay tablets, then baked in the hot sunlight. This is why many of the tablets are still in existence today. The Sumerian number system changed over the centuries. By about 3000 BCE, the Sumerians decided to turn their numbering symbols counterclockwise by 90 degrees. And by the 27th century BCE, the Sumerians began to physically write the numbers in a different way. Mainly because they changed writing utensils from the old stylus that was cylindrical at one end and pointed at the other to a stylus that was flat. This change in writing utensils, but not the clay, created the need for new symbols.
What were some early measurements of volume in terms of the gallon?
The names of the traditional volume units are the names of standard containers. Until the 18th century, the capacity of a container was difficult to accurately measure in cubic units. Thus, the standard containers were defined by the weight of a particular substance such as wheat or beer that the container could carry. For example, the basic English unit of volume, or the gallon, was originally defined as the volume of 8 pounds of wheat. Other volumes were measured based on this gallon. Depending on the different standard sizes of the containers. But like most measurements over time, not all gallons were alike. During the American colonial period, the gallons from British commerce were based on dry and liquid commodities. For dry, the gallon was 1/8 of a Winchester bushel, defined by the English Parliament in 1696 as a cylindrical container 18.5 inches in diameter by 8 inches deep, which held 268.8 cubic inches of material. It was also called a corn gallon in England. For liquid, in England the gallon measurement was based on Queen Anne's wine gallon. Also called the traditional British wine gallon, which measured exactly 231 cubic inches. This is why volume measurements in the United States include both the dry and liquid units. The dry units being about 1/6 larger than the corresponding liquid units. By 1824, the British weren't as satisfied with the gallon divisions as the Americans. In response, the British Parliament abolished all the traditional gallons and established a system based on the imperial gallon. It is still in use today, measuring 277.42 cubic inches. With the container holding exactly 10 pounds of water under specific, such as temperature and pressure, conditions.
How do scientists use mean sea level in connection with global climate change?
Many scientists are interested in the long-term mean sea level change, especially in connection with global climate change. By taking such long-term measurements, these scientists are hoping to confirm the predictions of several climate models, including the idea that global warming is a result of the greenhouse gases from either human or natural sources. There are two major ways to determine such sea level variations. The first estimates sea level changes using tide gauge measurements, mathematically averaging the numbers. Graphs of the most recent estimates using this method show a 0.669 to 0.960 inch 1.7 to 2.44 mm, rise in sea level per year. The second method uses Global Positioning System, GPS, devices and satellite altimeter measurements, both of which accurately pinpoint global ocean heights quickly and more efficiently. For example, from 1994 to 2004, scientists mathematically constructed graphs from satellite altimeter measurements, showing that the global mean sea levels have risen anywhere between 1.10 and 1.18 inches, 2.8 and 3.0 millimeters. No matter what the method, scientists do know the global mean sea levels are slowly rising. Many believe that about 1/4 of the rise is caused by thermal expansion as the oceans warm, and another 1/4 by small glaciers melting around the world. Some rise may also be caused by such human activities as burning trees, pumping groundwater, and draining wetlands. Currently, scientists are not quite certain about the true rate of sea level rise, mainly because of the intensity of working on the data. Ocean tide gauge records must be averaged over many decades, and corrected for variable ocean dynamics and distortions of Earth's crust.
What is a coordinate system?
A coordinate system is one that uses coordinates, a number or numbers that identify a point on a number line, plane, or in space. These points are most often seen on a graph and can be a combination of two numbers for a two-dimensional figure or three numbers for 3 dimensions.
Are there more advanced concepts in arithmetic?
Yes, arithmetic can even be more advanced than the ideas mentioned above. For example, higher arithmetic is the archaic term for number theory, which is the study of the properties of integers or whole numbers, 0, plus or minus 1, plus or minus 2. It can include anything from simpler arithmetic concepts to the more complex, such as Diophantine equations. For more information about these equations, see algebra, prime numbers, see below, and functions such as the Riemann hypothesis. For more about Friedrich Bernhard Riemann, see History of Mathematics and Geometry and Trigonometry. There are other more advanced ideas in arithmetic, too. For example, modular arithmetic is known as the arithmetic of congruences, see below. The model theory discusses the existence of non-standard models of arithmetic, and floating point arithmetic is performed on real numbers by computers or other automated devices.
What are some other examples of dissection puzzles?
There are several other examples of dissection puzzles, including the following. The haberdasher problem, Pythagorean square puzzle, T-puzzle. Puzzle inventor Henry Ernest Dewdney, 1857 to 1930. of England was instrumental in developing many more puzzles than the cryptarithmetic puzzle described above. One of the most famous of his geometrical puzzles is the haberdasher's problem, which asks how an equilateral triangle can be cut into 4 pieces and reassembled to form a square. His model used hinges that would move the pieces into place. In the Pythagorean square puzzle, the 2 squares on the left are combined to form a single large square on the right. The T puzzle is a dissection puzzle that forms the letter T. 4 pieces are used to create the capital letter, as seen on p. 425.
What is vector analysis?
Vector analysis is the calculus of functions with variables as vectors A. Part of calculus also known for its derivative and integral equations. The components of a vector do not always have to be constants. They can also be variables and functions of variables, such as the position of a body moving through space represented by a vector whose x, y, and z components are all functions of time. In this case, the calculus can be used to solve such vector functions, which are also called vector analysis.
What is conditional probability?
Conditional probability is often phrased as event A occurs given that event B has occurred. The common notation is a vertical line, or AB, set as a given B. Thus, P, A denotes the probability that event A will occur given that event B has occurred already. Since there is always room for improvement even in probability, conditional probability incorporates the idea that once more information becomes available, the probability of further outcomes can be revised. For example, if a person brings a car in for an oil change every 3,000 miles, it can be calculated that there is a probability of 0.9 that the service on the car will be completed within 2 hours. But if the car is brought in during a seatbelt recall, the probability of getting the car back in 2 hours might be reduced to 0.6. This is the conditional probability of getting the car back in 2 hours if there is a seatbelt recall taking place.
How are three-dimensional Cartesian coordinates determined?
The three-dimensional coordinates are those that describe a solid or three-dimensional object with 3 axes, or 3 planes, the usual 2 axes, as in the two-dimensional system, and an additional line. The coordinates are usually written in terms of x, y, and z, and are often called ordered triples or just triples.
What are non-vanishing and vanishing numbers?
A non-vanishing number means just what the term implies, a quantity that is non-zero everywhere. For example, in the expression x4 plus 1, the answer will never be 0. Even when x is 0 or a negative number. The answer for the expression x2 is called vanishing because if x equals 0, the expression's answer vanishes to 0.
What are exponents?
Exponents are actually shorthand for multiplications and represent the number of times a number is being multiplied, called the base. For example, 9x9 equals 92, or 9x9x9 equals 93. Another term for this process is raising to a power, in which the exponent, a number as a superscript, is the power. For example, 93 is 9 raised to the third power. It is also easier to write larger numbers with exponents. For instance, instead of writing xxxx, we can write x4. For more information about exponents, see algebra.
What happened to the Babylonians?
After the Amorites, a Semitic people, founded Babylon, there were several dynasties that ruled the area, including those associated with the famous king and lawmaker, Hammurabi, 1792 to 1750 BCE. It was periodically taken over, including in 1594 BCE by the Kassites and in the 12th century BCE by the Assyrians. Through all these conquests, most of the Babylonian culture retained its own distinctiveness. With the fall of the Assyrian Empire in 612 BCE, the Babylonian culture bloomed, at least until its conquest by Cyrus of Persia in 539 BCE. It eventually died out a short time after being conquered by Alexander the Great, 356 to 323 BCE. In 331 BCE, ironically, Alexander died in Babylon, unable to recover from a fever he contracted.
What are complex numbers?
Complex numbers have two parts, a real part, any real number, and an imaginary part, any number with an I in it. The standard complex number format is A and by, or a real number plus an imaginary number. It is also often seen as X and E because while real numbers are viewed on a line, complex numbers are viewed graphically on an argand, or polar, coordinate system. The imaginary numbers make up the vertical, or Y, axis as E, while the horizontal, or X, axis is occupied by real numbers. For more information about coordinate systems, see geometry and trigonometry.
What culture took the first steps toward timekeeping?
Around 5,000 years ago, the Sumerians in the Tigris-Euphrates Valley, today's Iraq, appear to have had a calendar, but it is unknown if they truly had a timekeeping device. The Sumerians divided the year into months of 30 days. The day was then divided into 12 periods, each corresponding to 2 of our modern hours, and the periods into 30 parts, each corresponding to 4 of our minutes. Overall, many researchers agree that the Egyptians were the first serious timekeepers. Around 3500 BCE, they erected obelisks, tall, four-sided monuments, placing them in specific places in order to cast shadows as the sun moved overhead. This thus created a large, crude form of a sundial. This sundial time was broken into 2 parts, before noon and afternoon. Eventually, more divisions would be added, breaking down the time units even more into hours. Based on the length of the obelisk's shadows, the huge sundials could also be used to determine the longest and shortest days of the year.
Who invented the symbol for zero?
Although the Babylonians determined there to be an empty space in their numbers, they did not have a symbol for zero. Archaeologists believe that a crude symbol for zero was invented either in Indochina or India around the 7th century and by the Mayans independently about 100 years earlier.
What is perspective?
In painting and photography, perspective gives an image depth, allowing a person to perceive 3 dimensions in a 2-dimensional picture. In art, this can be achieved using certain tools of the trade. For example, the horizon line is the eye level of the artist and viewer. By raising and lowering the viewpoint, it enables the viewer to see more or less of the horizontal plane that lies between the viewer and the horizon. The vanishing point is a point on the horizon line at which parallel lines seem to meet. The classic example is how train tracks seem to come together in the distance. The horizontal baseline is parallel to the horizon line and represents the base of the picture plane. The vanishing point is on the horizon line and is directly opposite, or in front, of the viewer. All of these points, lines, and angles and other ways of bringing depth into a painting are based on concepts in mathematics.
How do geologists measure the intensity of earthquakes?
Geologists measure the intensity of earthquakes in order to compare and judge potential damage. One of the first standard ways to measure intensity was developed in 1902 by Italian seismologist Giuseppe Mercalli, 1850 to 1914, and is called the Mercalli Intensity Scale. It was later modified and renamed the Modified Mercalli Intensity Scale. The numbers, in Roman numerals from I to 12, represent the subjective measurement of an earthquake's strength based on its effects on local populations and structures. For example, Roman numeral V on the scale represents a quake felt by nearly everyone. With some dishes and windows broken, unstable objects overturned, and disturbances of trees, poles, and other tall objects sometimes noticed. But scientists wanted a more solid, less subjective scale. One of the first scales developed to measure the true magnitude was invented by American seismologist Charles Francis Richter. 1900 to 1985, and German-born seismologist Bino Gutenberg, 1889 to 1960. In 1935 these scientists borrowed the idea of magnitude from astronomers. Stellar brightness is measured by magnitude, defining earthquake magnitude as how fast the ground moved. As measured on a particular seismograph a specific distance from the quake's epicenter. The Richter scale is not a physical scale like a ruler, but rather a mathematical construct. It is not linear, but logarithmic. Thus, an increase in each whole number on the scale represents a tenfold increase in power. Its numbers represent the maximum amplitude of seismic waves that occur 62 miles. 100 kilometers, from the epicenter of an earthquake. Because seismographs are usually not located at this exact interval, the magnitudes are deduced using the arrival of specific waves of energy given off when an earthquake occurs.
How did Jainism influence mathematics in India?
Jainism was a religion and philosophy founded around the 5th century BCE. Following the decline of the Vedic religion on the Indian subcontinent, along with Buddhism, it became one of the area's main religions. Over the next several centuries, Jainism also became a major influence in Indian science and mathematics. It was steeped in cosmological ideas in which time was thought of as eternal and without form. The world was also considered to be infinite and to have always existed. In fact, their cosmology included time periods with numbers larger than our modern guesses about the universe's age. Even their astronomical measurements came close to some of our modern values. For example, the synodic lunar month was thought to be 29 and 16/31 days. 29.51612903 days, the correct value is 29.53058888. Jainism also produced a plethora of mathematical ideas, some of which were surprisingly advanced for their time.
They are listed as follows: n indicates natural numbers or integers, x represents real numbers. Z stands for complex numbers. What are some other terms used in dealing with algebraic equations?
There are many terms in algebra, including those dealing with equations. The following lists some of the more common ones. Equality and inequality. An equality is a mathematical statement that shows the equivalence of two quantities. For example, if A is equal to B, it is written as the equality A equals B. An inequality is just the opposite, A does not equal B, or A asterisk B. Formula. A formula is a rule, fact, or principle expressed in terms of mathematical symbols, including equations, equalities, identities, or inequalities. Note, the plural of formula in Latin is formulae, but it has become more readily accepted as formulas. Identity. An identity is a mathematical relationship equating one quantity to another that initially may appear to differ. It also means an equation that is always true, such as the Pythagorean theorem. For more about identities, see below.
What contributions did David Hilbert make to mathematics?
German mathematician David Hilbert, 1862 to 1943, contributed a great deal to mathematical logic, as well as mathematics in general. In 1890, his proof of the theorem of invariance replaced earlier work on the subject and paved the way for modern algebraic geometry. By 1897, his algebraic number theory led to many developments in that field. His contributions also included discoveries in number theory, mathematical logic, differential equations, multivariable calculus, Euclidean geometry, and even mathematical, theoretical, physics. Hilbert is most well known for presenting Hilbert's problems, which originally were a set of 23 unsolved mathematical problems that he hoped would eventually lead to many more disciplines within the field of mathematics. His idea worked, as mathematicians attempted to solve the problems. Their efforts led to mathematical discoveries in the 20th century. Although a number of the problems have yet to be solved. For more information about Hilbert, see History of Mathematics.
What are some simple rules of exponents?
There are several simple rules when it comes to exponents. These include the following: the equation x1 equals x, or a number raised to the 1 power is the number itself. This is also called the rules of 1. The equation x0 equals 1, unless x equals 0, which is considered undefined. This is also called the zero rule. A number without an exponent has an exponent of 1, as in 20 equals 201. A negative exponent indicates that the number is to be divided by the exponent instead of multiplied. For example, 3 to 3 is equal to 1/33, or 1/27. But there is a restriction to this rule. Xn equals 1/xn only when x is not 0. If x is 0, then xn is undefined.
What is an indirect proof?
Direct proofs begin with a true statement and then proceed to prove that a conclusion is true. But there is also a method called the indirect proof in which indirect reasoning is used. First, assume that the conclusion is false, then show that this assumption leads to a contradiction of the hypothesis or some other accepted fact, such as a postulate or theorem. Therefore, if the assumption is proved false, the conclusion has been proved indirectly to be true.
What is a transit?
The transit, or adiator, is credited to J. Transit of France, who invented the device in 1889. He called it his arithmography. In actuality, his work was based on earlier designs that were first started by Claude Peyroux 1613 to 1688. It was used principally for addition and subtraction. A transit's flat, mechanical, palm-held calculator had three main components. The part for the calculation, a stylus, and a handle to reset the adiator. By inserting the tip of the stylus into notches along a metal plate, numbers could be added by sliding either up or down strips of metal with numbers marked on them. No gears or interlinked parts were involved. To carry one when the sum of two digits was greater than 10. The stylus was moved up to and around the top of the device.
Is it possible to simplify logarithms?
Yes, as in algebraic equations, it is possible to simplify logarithms, but in different ways. The following lists some examples: to simplify log 3, x, plus log 3, y, equals log 3, xy. To simplify log 3, 6, log 3, 4, equals log 3, 6/4. To simplify 2 log, x, equals log, x2.
What were the ancient definitions of a foot?
Not all feet, or the foot, are created equal. The term foot in measurement has had a long history, with many stories claiming the origin of the first foot status. In fact, it seems as if the foot has ranged in size over the years from 9.84 to 13.39 inches. 25 to 34 centimeters, depending on the time period and / or civilization. For example, the ancient Harappan civilization of the Punjab, from around 2500 to 1700 BCE, used a measurement interpreted by many to represent a foot, a very large foot. At about 13.2 inches, 33.5 centimeters, see above for more about the Harappan. Around 1700 BCE, the Babylonians put their foot forward. A Babylonian foot was 2/3 of a Babylonian cubit. There are even records from Mesopotamia and Egypt showing yet another Measurement system that included a foot of 11.0238 inches, 300 millimeters. This was also known as the Egyptian foot, and it was standard in Egypt from pre-dynastic times to the first millennium BCE. The Greek foot came close to today's foot, measuring about 12.1 inches. 30.8 centimeters, a Roman foot measured in at 11.7 inches, 29.6 centimeters. The list goes on, depending on the country and time period.
What is mathematical biology?
Mathematical biology is another word for biomathematics. The interdisciplinary field that includes the modeling of natural biological processes using mathematical techniques. Mathematical biology is carried out by mathematicians, physicists, and biologists from various disciplines within their fields. These scientists work on such problems as modeling blood vessel formation, with possible applications to drug therapies, modeling the electrophysiology of the heart, exploring enzyme reaction within the body, and even developing models that track the spread of disease.
What are skewness and symmetry?
Skewness is when there is asymmetry in the distribution of the sample data values. In this case, the values on one side of the distribution seem to be further from the middle range than values on the other side. Symmetry essentially means balance, when the data values are distributed in the same way above and below, or on both sides of the middle of the sample.
What is differences of squares?
Differences of squares is another way to factor an expression into a form that is essentially something 2 subtracted from something 2. Mathematically, an equation that resembles a 2x2b2 is a difference of squares and can be factored into ax and b, ax b, with the factors being identical, except for the sign. This, in turn, equals ax, ax, abx and abxb2. The two middle terms, abx and abx, further cancel each other out, resulting in a 2x2b2, which results in a way of factoring called the difference of squares. For example, take the expression 16s2 from the above. We know that the form, a 2x2b2, equals ax and b, ax b. Thus, by substitution, and if a equals 1, x2 equals 16, and b equals s, we can say that 16s2 equals 4 plus s, 4s, with the resulting factoring of the equation using difference of squares.
How is the product of two vectors determined?
There are two distinct types of products of two vectors, scalar and vector products. Sometimes called the inner and outer products, mostly in reference to tensor products, see below. The scalar, or dot, product of two vectors is not a vector, because the product has a magnitude but not a direction. For example, if A and B are vectors, of magnitude A and B, respectively, their scalar product is, AB equals ab cos 8, in which 8 is the angle between the two vectors. This scalar quantity is also called the dot product of the vectors. These equations obey the commutative and distributive laws of algebra. For more information, see algebra. Thus, AB equals BA, A, B plus C, equals AB plus AC. If A is perpendicular to B, then AB equals 0. The vector, or cross or skew, product of A and B is the length C equals ab sin 8, its direction is perpendicular to the plane determined by A and B. In this case, this kind of multiplication does not follow the commutative law, as AB equals BA.
What mathematical concept was featured in the movie The Andromeda Strain?
The concept of exponential growth, also known as geometric growth, provided the tension in this movie and the book on which it was based. The basic premise was that microscopic organisms had been inadvertently brought to Earth from outer space by a returning satellite. Once on Earth, they reproduced exponentially, doubling in number every 20 minutes. Very quickly, they spread over the entire planet, killing nearly everyone. And no, we won't give away the ending.
How is mathematics used in chemical engineering?
Mathematics is used a great deal in chemical engineering, especially since chemical engineers design materials and the processes by which those materials are made. To solve chemical problems, many types of mathematics are used, not least of which is calculus, including partial differential equations. Even simple calculations, such as working on chemical formulas and equations, involve mathematics. For more information about chemical formulas and equations, see Math in the Physical Sciences. Traditionally, chemical engineers worked in the petroleum and large-scale chemical industries. More recently, they have spread out to the pharmaceutical, foodstuff, polymer and material, microelectronics, and biotechnology industries. Using mathematics, they are involved in such studies as thermodynamics, chemical reaction processes, and process dynamics, design and control. They help to develop new chemical products and processes, test processing equipment and instrumentation, gather data, and monitor quality. Chemical engineers also build mathematical models and analyze the results, mostly to help understand the performance of a process. In fact, the solution to a math problem is often in the understanding of the behavior of the process described by the mathematics, rather than the specific numerical result.
What is the discriminant of a quadratic equation?
In the quadratic equation x2 plus bx plus c equals 0, the value of b2 for ac is the discriminant. The same numbers and letters that are under the square root sign of the quadratic formula. This is actually the products of the squares of the polynomial root differences. In other words, this quantity characterizes certain properties of the quantity's roots. The discriminant is often used for such mathematical concepts as metrics, modules, quadratic fields, and polynomials.
What are axioms and postulates?
These two words are often treated as the same, in fact. Some mathematicians consider the word axiom a slightly archaic synonym for postulate. Although both are considered to be a proposition, statement that is true without proof, there are subtle differences. An axiom in mathematics refers to a general statement that is true without proof, and it is often related to equality, such as two things equal to the same thing are equal to each other, and those related to operations. They should also be consistent. It should not be possible to deduce any contradictory statements from the axiom. A postulate is also a proposition, statement, that is true without proof. But it deals with a specific subject matter, such as the properties of geometric figures. Thus, it is not as general as an axiom. For example, Euclidean geometry is based on the 5 postulates known, of course, as Euclid's postulates. See below, for more about Euclid, see History of Mathematics and Geometry and Trigonometry.
What are logical operators in predicate calculus?
Predicate calculus commonly uses 7 special symbols called logical operators to express a formula. In this case, a formula is a meaningful expression built up from atomic formulas by repeated application of the logical operators. The following table lists the symbols and their meanings.
What is the importance of pi?
It was used in calculations to build the huge cathedrals of the Renaissance, to find basic Earth measurements. And it has been used to solve a plethora of other mathematical problems throughout the ages. Even today it is used in the calculations of items that surround everyone. To give just a few examples, it is used in geometric problems, such as machining parts for aircraft, spacecraft, and automobiles, in interpreting sine wave signals for radio, television, radar, telephones, and other such equipment, in all areas of engineering, including simulations and the modeling of a building's structural loads, and even to determine global paths of aircraft. Airlines actually fly on an arc of a circle as they travel above the Earth.
What is a polynomial?
In its simplest form, a polynomial is a mathematical equation that involves a sum of powers in one or more variable, all of which is multiplied by coefficients. In such equations, variables and numbers on both sides of the equal sign are considered polynomials. For example, by expanding out the expression, x2, 3, or multiplying out the equation, we discover that x2, 3 equals x3 6x2 plus 12x8, which is a polynomial equation.
What is Avogadro's number?
Avogadro's number, also called Avogadro's constant or Avogadro's figure, was determined by Italian physicist Lorenzo Romano Amadeo Carlo Avogadro, Count of Quaregna and Cerreto. 1776 to 1856, who was also the first one to use the term molecule in chemistry. It represents the number of elementary entities, such as atoms, molecules, or formula units. In a mole of any chemical substance, a mole is approximately 6.02214199 x 1023 atoms. According to the most recent number from the National Institute of Standards and Technology. To translate even further, a mole is the molecular weight of a substance in grams. 1 mole is the amount of a substance that contains Avogadro's number. For example, the number of carbon atoms in 12 grams of the substance carbon-12 is equal to 1 mole.
What are survivorship curves?
Survivorship curves record and plot the fate of the young and their chances of survival in key age categories. Significant factors affecting all populations are birth rates, death rates, and longevity. By recording the numbers of births and deaths over a period of time, researchers can determine the average longevity of organisms in each age class. These numbers tell a great deal about a population. There are 3 basic survivorship curves. Type I curves represent species that have offspring with a high survival rate, with most living to a certain age and then dying. Humans are an example. Type II curves represent organisms with a steady death rate from the time they are born or hatch until they die. Their survivorship varies and includes such species as deer, large birds, and fish. Type III curves include those organisms that have a low survivorship shortly after being born. but with a high longevity for the individual organisms that survive. Maple and oak trees can be included in this category.
What was the progression of logarithm development?
The invention of logarithms was a long process, starting with Scottish mathematician John Napier. 1550 to 1617, also known as Laird of Merchiston, who first came up with the idea of logarithms in 1594. But the actual invention and announcement of logarithms would take another 20 years. In 1614, Napier would publish Mirifici Logarithmorum Canonis Descripto. Description of the wonderful canon of logarithms, which offered tables and rules for their use. Not long afterward, in 1617, English mathematician Henry Briggs, 1561 to 1630, published Logarithmorum Cilius Prima, logarithms of numbers from 1 to 1000. Introducing the concept of common logarithms or logarithms based on the powers of 10. And finally, independently from Briggs and Napier, came Swiss mathematician Just Bürgi, 1552 to 1632. Who in 1620 presented Arithmetisque und Geometrische Progresstabulum, a German work presenting the discovery of logarithms. These discoveries differed in several ways. Napier's approach was algebraic, Bürgi's was geometric. There were differences from the common and natural logarithms we use today. And neither Napier nor Bürgi mentioned the concept of a logarithmic base, something that Briggs presented. By 1624 Briggs would write Arithmetica Logarithmica, the arithmetic of logarithms, extending his common log tables from 1 to 20,000 and from 90,000 to 100,000. But the work on logarithms did not end with Napier. Briggs, or Bürgi. Natural logarithms eventually evolved out of Napier's original work. Defining logarithms as exponents was finally recognized by English mathematician John Wallis. 1616 to 1703, who presented them in his 1685 publication, De Algebra Tractatus, Treatise of Algebra.
How are modern abaci used?
Today's standard abacus is typically constructed of wood or plastic and varies in size. Most are about the size of a small laptop computer. The frame of the device has a series of vertical rods or wires on which a number of wooden beads slide freely. A horizontal beam separates the frame into two sections called the lower and upper decks. For example, in a Chinese abacus, the lower and upper decks each have 13 columns. The lower deck has 5 beads per column, while the upper deck has 2 beads. Each bead on the upper deck has a value of 5, while each bead on the lower deck has a value of 1, thus, it is called a 1/5 abacus. To use the abacus, users place the abacus flat on a table or their laps. They then push all the beads on the upper and lower decks away from the horizontal beam. From there, the beads are manipulated. Usually with the index finger or thumb of one hand, to calculate a problem. For example, if you wanted to express the number 7, you would move 2 beads in the lower deck and 1 bead in the upper deck. 1 plus 1 plus 5 equals 7. This modern abacus is still used by shopkeepers in Asia and many so-called Chinatowns in North America. Students continue to be taught how to use the abacus in Asian schools, especially to teach children simple mathematics and multiplication. In fact, it is an excellent way to remember multiplication tables and is useful for teaching other base numbering systems, because it can adapt itself to any base. For more about base numbers, see History of Mathematics and Math Basics.
What are rational, irrational, and real numbers?
Rational, or fractional, numbers are most often regarded as divisions, or ratios, of integers. By creating a fraction, dividing one integer by another. A rational number produces either a number that ends or repeats decimals. For example, 1/4 equals the decimal equivalent of 0.25. 1/3 is equivalent to 0.33333. Both of these are rational numbers. For more information about fractions, see p. 98. On the other hand, irrational numbers are all the numbers that can be written as non-repeating, non-finite, or non-terminating decimals. Also called non-rational numbers, they include the decimal equivalent of pi, or 3.141592. Finally, if you put the rational and irrational numbers together, they form the real numbers. Most numbers we use in our everyday lives are real numbers.
What are some terms to know when getting a credit card?
There are several terms, many that include a bit of mathematics one should know when getting a credit card. An important one is the annual fee, which is often charged by the credit card company and is a flat, yearly charge similar to a membership fee. A finance charge is the dollar amount you pay to use credit. It should be listed on your credit card statement. It usually includes the interest on the borrowed money and other charges associated with transactions, such as cash advance fees or exchange rate calculation fees when paying for an item in a foreign country. As stated in the question above, the annual percentage rate, APR, is a measure of the cost, or relative cost, of credit on a yearly basis. With credit cards, APR commonly includes interest and other charges, such as a yearly rate. Credit cards often offer two types of interest rates, too. In the variable rate plan, as the name implies, the interest is variable. It is usually tied to other interest rates, such as the Treasury bill or prime rates. A fixed rate plan is a rate not tied to changes in other interest rates, it remains steady. Unless the credit company raises or lowers rates for everyone, which they can periodically do.
Can a fraction's numerator be 0?
In the context of division, see above, we learned that it is not possible to divide by 0, which is labeled an undefined number. But you can have 0, 0, as your numerator, and any allowed fraction, one that doesn't have a 0 in the denominator. That has 0 as its numerator will always be equal to 0. For example, 0/5 and 0/345 both equal 0.
What are implicit and explicit differential equations?
As seen above, an ordinary differential equation is one involving x, y, 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 and so on. Now add the idea that the order of the highest derivative is n. Thus, if a differential equation of order n has the form f, x, y, 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 n, equals 0, then it is called an implicit differential equation. If it is of the form f, x, y, 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 n 1, equals y, n, it is called an explicit differential equation.
What are the concepts of convergent and divergent sequences?
Convergent and divergent sequences are based on the limit of a sequence. A convergent sequence, the one most commonly worked on in calculus, means that one mathematical sequence gets close to another and eventually approaches a limit. Convergence can also apply to curves, functions, or series. This is seen visually when a curve approaches the x or y axis but does not quite reach it.
What is the definition of a conic section?
This family of curves first discovered, as far as we know, by the ancient Greeks is generated by planes intersecting, cutting into, a cone. The resulting feature depends on the angle between the plane and the axis of the cone, with none of the planes passing through the endpoint, vertex, of the cone. Each plane that cuts a cone creates a two-dimensional figure called a section. Thus the resulting figures are called conic sections or conics. In general, the possible resulting surfaces are a sphere, the cut perpendicular to the axis, ellipse, or the circle as a special case, a cut moderately inclined to the axis, parabola, a cut parallel to one of the straight lines that generate the cone, and hyperbola. Using two cones tip to tip, the cut even more steeply inclined than all the others.
What are time zones?
Time zones are any of the 24 regions on the globe, loosely divided by longitude but more erratic in their demarcations, which is divided according to the number of hours in a day. Within each zone, all clocks are set to the same time. Time zones include the International Date Line, an imaginary line of longitude generally 180 degrees east or west of the prime meridian. The date becomes 1 day earlier to the east of this line. Time zones are truly a product of mathematics. Initially, people used local solar time, resulting in slightly different times between towns. With technology, especially trains and telecommunications, more accurate timekeeping became a necessity. Thus, time zones help solve many of the problems by setting the clocks of a region to the same mean solar time. The time zones made it easy for neighboring time zones to be labeled 1 hour apart. Not that the system is perfect. The hour separation is not universal. And because they often follow political boundaries, the shapes of the time zones can be extremely irregular.